Hello everyone, let us do one another example of projection of solids. So here is the statement of the example. A pentagonal pyramid, age of the base 50 mm, height 75 mm, is resting on a corner of its base on HP in such a way that the slantage containing that corner makes an angle of 60 degree with HP and 30 degree with VP. Draw the projections. So here the pentagon is resting on its corner on HP. It is resting on its corner on HP. So in the first stage we have to draw the pyramid or the plan and elevation of the pentagonal pyramid like this by taking the corner on the right hand side. So starting with the plan and elevation in the first stage, it is resting on corner of its base on HP, so the corner will remain on the right hand side. So start with the top view of the pentagon, and we all know that the top view of the pentagonal pyramid, and we all know that the top view will be a pentagon by taking the corner on the right hand side. Starting with the base edge, so draw the base edge. The length of the base edge is 50 mm perpendicular to the XY reference line. Then after, measure the angles of 72 degree from this corner and this corner like this. If you want to draw the pentagon, 72 degree angle and 72 degree angle from here also. After drawing the angle at the 72 degree, measure 50 mm distance on the router, give an arc to mark the point B. From D, give an arc to mark the point E, and again give an arc from E and B. It will give us point A. Now mark the point A, B, C, D, E. It will be the base of the pentagonal pyramid in the top view. Then I want to mark the center, and if you want to mark the center, find the midpoint of one of the base edge and join that midpoint to opposite corner. Then after, find the midpoint of one another base edge and join that midpoint to the opposite corner. The intersection of these two lines will give us the center of the pentagon, and the center of the pentagon will give us the top view of the apex point. Now join the apex point to the base corners, that is OA, OB, OC, OD and OE. This will be the top view of the slant edge OA, OB, OC, OD and OE. Now draw the elevation. For that, project the points upwards, DE, apex point, CD. Make sure that the projection should be perpendicular to the XY line, and mark the point A dash, B dash and E dash, C dash and E dash, and draw the base. The base will be the the elevation of the base will be a line. Now on the projection of the apex point, measure the axis height perpendicular to the XY reference line, and axis height is 75 mm. Mark point O dash and join O dash to the base corners, that is O dash A dash, O dash B dash, O dash C dash, O dash D dash and O dash A dash. So this will be the elevation. Now here the pentagonal pyramid is resting on HP. So in the second stage we have to derive the condition with the horizontal plane. So the condition with the horizontal plane is like this. It is resting on HP on a corner of its base on HP in such a way that the slant edge containing that corner makes an angle of 60 degree with HP. So we have to draw the condition with the horizontal plane in the second stage, because the pyramid is resting on HP. So in the second stage we have to derive the condition with the horizontal plane, and the third stage we have to derive the condition with the vertical plane. Now one of the slant edge, if we draw the pentagonal pyramid resting on base corner, and if we draw the elevation, the slant edge will be over here, slant edge containing the corner A, okay, because the pyramid is going to rest on corner A. So the slant edge containing dot corner will be the O dash A dash or OA. So we have to take the angle with the horizontal plane, so we have to incline the elevation of the slant edge O dash A dash at an angle of 60 degree. So measure the angle of 60 degree angle. Now we have to take the slant edge, because here it is given the slant edge containing the corner. Which corner? The corner which is on HP. And which corner is going to be remain on HP? Corner A is going to be remain on HP. So measure O dash A dash, give an arc on the line which we have taken, or which we have already taken, showing the angle of 60 degree O dash. So now O dash, if you want to mark O dash to C dash D dash, measure O dash to C dash D dash. O dash to C dash D dash, give an arc. Now A dash to C dash D dash, give an arc. So this will be the C dash D dash. Now draw this triangle. After drawing the triangle, measure C dash D dash to B dash E dash B dash, give an arc. So this is B dash E dash. And also measure the axis. So this will be the axis, and complete the figure. After completing the figure, we have to draw the plan in the second stage. So first of all, if you want to draw the plan, we have to project the points from the elevation. O dash, O dash, A dash, A dash, B dash E dash, B dash E dash, C dash E dash, that means C and D on this line. Mark the points, and now we have to draw the plan using the one of the case, that is case 1, case 2 or case 3, that we have already discussed in problem 1, 2 and 3. In problem 1 we have discussed the case 1, in problem 2 we have discussed the case 2, and in problem 3 we have discussed the case 3. So you have to find out any of the case. So now here in this example we are going to apply the case 1, because as per the case 2 we have discussed that in the case 2 this slant edge should be perpendicular to the XY reference line. This slant edge should be perpendicular to the XY reference line, or the angle of this slant edge should be 90 degree or more than 90 degree if you want to apply the second case. So we are not going to apply the second case, because right now the angle of this slant edge is less than 90 degree, not 90 degree or more than 90 degree, but it is less than 90 degree. So we are not going to apply the second case. Now what about the third case? In third case we have discussed that the point should be rotated like this, or the points of the base should be rotated like this, but here the points remains as it is. So in this question we are not going to apply case 3 also. So we are not going to apply case 2 and case 3 in this example, because the condition of this example doesn't follow the case 2 and case 3. So we are going to apply the case 1, in which we have to observe the object from the observer side, and if we are going to observe the object from this observer side, this edge is going to be visible, that is O dash C dash D dash. So draw O dash C dash D dash, that is OCD is going to be visible. This is O1 C1. This triangular face is going to be visible. If we have a object, then we can easily say that which slant edge or which base is going to be visible, or which base edge is going to be hidden, or which slant edge is going to be hidden. So right now it is in corner. This is the elevation. We have to incline the slant edge at an angle of 60 degree, and this is the plan. Now you can see that this triangular face is visible, this slant edge is visible, this slant edge is visible, and this slant edge is not visible. Which slant edge? The slant edge containing the corner is not visible. Okay, now how can we find out by using the drawing only, because always we doesn't have the object with us. So let us try to find out the visible and hidden outline there. Now as per our rule, we have drawn O1, D1, C1 as a visible outline. Now draw the slant edge OE and OB. If the slant edge OE and OB are outside of this triangular face, then it is going to be visible it is going to be visible. We can also discuss one another case, that the maximum base corners, that is the base corner nearer to the observer and base corner nearer to the XY line and base corner nearer to the observer. In between these two base corners, that means the base corner containing O1 E1 and O1 B1, or the slant edge containing E1 and B1 is going to be visible because E1 is nearer to VP, or we can say that these are the maximum points, or nearest corner to VP and nearest corner to observer. So from the top it is going to be visible, or we can also say that it comes outside this visible part. So O1 E1 is going to be visible, O1 B1 is also going to be visible because it is outside of this visible part. So now O1 B1 is visible, O1 C1 is visible, so by default C1 B1 is going to be visible, O1 D1 is visible, O1 E1 is visible, so D1 E1 is going to be visible. Now by the rule of intersection, E1 and A1 is going to be hidden because it intersects this visible outline. B1 A1 is going to be hidden because it intersects this line, and O1 A1 is going to be hidden because it comes inside this triangular face, inside. So O1 A1 is hidden. So to draw the second stage, we have applied the case 1 in this example. Now third stage, here it is given that the slant edge containing the corner makes an angle of 60 degree with HP and 30 degree with VP. Slant edge containing the corner makes an angle of 30 degree with VP. Slant edge, not plan of the slant edge. So here is the slant edge containing the corner makes an angle of 30 degree. So measure 30 degree. Here I have drawn a line parallel to the XY line. Below the XY line I have marked a point O dash, and at the angle of 30 degree I have inclined the slant edge, or I have measured the length of the true length of the slant edge, because here it is given slant edge makes an angle of, not plan of the slant edge. So we have to take the true length at an angle of 30 degrees. So here I have taken the true length at an angle of 30 degrees. Now we have to draw this figure over here, and this is the plan. So now we have to find out the angle for the plan of the slant edge OA. So if we want to find out the angle for the plan of the slant edge OA, we have to draw a line parallel to the XY line from O dash. That means we have to draw the locus from O dash. They have to measure O1 A1 and give an arc from the A dash. It will be exactly makes tangent to this line, or this line will be tangent to this arc. So O1 will be over here. So this is O1 A1. Now copy this figure over here, as we have already marked O1 A1. With reference to O1 A1, copy this figure over here. Now if you want to copy this figure, how can we copy this figure? So first of all, mark this point of this projector EB. Mark this point over here, mark this point over here. After marking this point, draw lines perpendicular to this line. That means we have to draw this line perpendicular, this line perpendicular. So from this point and this point we have to draw lines perpendicular to the line O1 A1. So draw line perpendicular to this particular line. So this is perpendicular line. Now measure this distance E1 and B1. So this will be E1 and B1. Now measure this distance B1 and C1. So this will be B1 C1. Mark the points, copy this figure. Now comes on the elevation. Here we can say that theta plus phi is equal to 90 degree, and beta is equal to 90 degree, and alpha is also going to be equal to 90 degree. This is alpha and it is also 90 degree. So beta is equal to 90 degree, that we have find. So now here also the base is nearer to the observer, and if the base is nearer to the observer, in the elevation base is going to be visible. So project the points of the base A, B, C, T, E, A, B, C, D, E. Mark the points and O dash also, and draw the base dark. A, B, C, D is going to be dark. Now draw the slant edge by using the rule of the intersection of the lines. Two visible line will never intersect, two hidden line will never intersect. So O1 D1 is visible, O1 C1 is visible, O1 B1 hidden due to intersection, O1 A1 hidden due to intersection, O1 E1 is hidden due to intersection. Now let us do one another example. Okay. Now hexagonal pyramid base 25 mm and axis 55 mm long has one of its slant edge on HP, slant edge on HP, a plane containing that edge means that slant edge. Which slant edge? The slant edge that we have to take on HP. That slant edge and the axis is perpendicular to HP and inclined at 45 degree to VP. Draw the projection when the apex is nearer to VP than the base. So here the condition of the slant edge is given, and we have to take the slant edge on HP, but for that we have to draw the first edge showing the corner on the right hand side, and right now it is the hexagonal pyramid. So in the plan we have to draw the hexagon of 25 mm side. So for that we have to draw a circle having radius is equal to 25 mm. So draw the circle having radius is equal to 25 mm. Now we have to take the corner on the right hand side. So give an arc from this corner equal to the radius of the circle FB, and from D give an arc E and C. So mark A, B, C, D, that will be the base. And now to find the center by joining the diagonals of the hexagon. That center will be the plan of the apex point. Now join the apex point to the base corner. It will be the plan of the slant edge. Project the points up to the XY reference line A, B, C, E and D. This will be the elevation of the base. Project the apex point. Measure the axis height. Mark the elevation of the apex point. After marking the elevation of the apex point, join the apex point to the base corners, that is O dash, A dash, O dash, B dash, O dash, C dash, O dash, D dash, O dash, E dash, O dash, F dash. So this will be the elevation of the hexagonal pyramid in the first stage. Now here we have the corner and we have the slant edge containing that particular corner. We have the slant edge containing that particular corner. So here we have the slant edge, and we have to take the slant edge on HP, not perpendicular to HP, that we have already taken. Once we have shown the triangular face perpendicular. Now we are showing the slant edge. If you want to show it perpendicular, we have to draw O dash, A dash perpendicular to XY line, and if you want to show on HP, we have to take the O dash, A dash on XY line. And if you want to take any angle, like we have taken in the example number 5, pentagonal pyramid, then we can also show the angle. So right now we have to take O dash, A dash on HP because it is given in the question. Slant edge is on HP. So we have to take O dash, A dash on XY line. So measure O dash, A dash and take it on the XY reference line. O dash, A dash. Now copy this figure. O dash, D dash, O dash, D dash, A dash to D dash, A dash to D dash. Draw the triangle, mark the points on the base ACE, A to CE and D to BF, mark the points, project the points vertically downwards and draw the locus of point A, B, C, D horizontally right hand side. O, A, B, F, C, E and D. Mark the points and draw the plan in the second stage by defining any one case. Now I hope that you can understand which case we are going to apply in this example, because here it is clearly visible that the point A is on right hand side and in the plan it goes on the left hand side. So now points are rotated. Here point A is here, and in this figure point A is here. So base is going to be visible like this. Corner is here, and if we rotate it like this, corner A will be on the left hand side. So base is going to be visible. And if base is visible in the second step, first of all draw the base. So draw the base AB, BC, CD, DE as visible outline, because base is going to be visible. Now draw the slantage, applying the rule of intersection of the visible outline and hidden outlines. That is, two visible outlines will never intersect, two hidden line will ever intersect. So draw OD. OD is visible, no intersection in between O1 D1. O1 C1 visible, no intersection in between O1 C1. O1 E1 visible, no intersection in between O1 E1. O1 F1 hidden, intersection at the bases ED, so it is going to be hidden. O1 V1 is hidden due to intersection, and O1 A1 is hidden due to intersection of these bases CD and DE. But here we will show the hidden outline of OA in between A1 and D1, because over here the slantage O1 D1 will hide the hidden outline of the O1 A1. So this is the plan. Now here is a typical statement to derive the third stage. We have the angle, but the statement is little bit typical. Plane containing the slantage and the axis makes an angle of 45 degree to HP. Which slantage? The slantage which is on HP. So we have to take a plane containing the slantage and the axis, and we have to incline that particular plane. And if we incline the particular plane, the edge and the axis that the plane is going to contain will incline with the plane. So right now we have to take the slantage OA and OA, the slantage OA and the axis. So the plane containing the slantage OA and the axis is like this, because here the axis and OA is on the same line, so it will be a vertical plane. So the vertical plane containing the axis, we can also say that the vertical plane containing the axis, because the slantage containing the plane containing the slantage and the axis will be a vertical plane, and it is going to be inclined at an angle of 45 degree. And if the plane is inclined at an angle of 45 degree, the edges or axis that the plane contain is going to incline at an angle of 45 degree. So right now the plane is containing O1 A1 and the axis. So the O1 A1 and axis are going to be inclined at an angle of 45 degree. So the copy this figure over here by taking O1 D1 and A1 at an angle of 45 degree. So measuring O1 D1, draw the angle of 45 degree, measure O1 D1, mark O1 D1, measure O1 A1, mark O1 A1. So O1 D1 A1, now A1 to F1, A1 to F1 even arc, A1 to B1 will remain also same. This will remain same. So A1 to B1, this will also remain same, E1 and C1. So D1 to E1 arc, C1 arc. Now we have to find out the intersection to mark the points. So now measure, first of all we have measured A to F. Now measure D to F. It is equal to D to B, it is equal to A to E and A to C. So give an arc like this, it will give us the intersection 1, 2, 3 and 4, and mark C1, E1, F1. Copy this figure over here, project the points vertically upwards, and from here, so A, B and F. So B and F, C, E. So C and E, D, O, and the line of the axis. Now here again the base is nearer to the observer, and it is also given that when the apex is nearer to VP, so apex is nearer to XY line, so apex is nearer to XY line, so base is nearer to the observer. So base is nearer to the observer, so then the elevation base is going to be visible. So draw the base A1, B1, C1, D1, E1, F1 as a visible outline. Now draw the slantage by using the rule of intersection. So O1 A1 O1 dash A1 dash is visible, O1 B1 is visible, O1 C1 is visible due to it doesn't have any intersection in between O1 A1, O1 B1 and O1 C1. So O1 A1 and O1 dash A1 dash, O1 dash B1 dash, O1 dash C1 dash is going to be visible. Now O1 D1 hidden due to intersection, O1 E1 is hidden due to intersection, and O1 F1 is hidden due to intersection. Draw the axis and complete the figure. Thank you.